Welcome everyone to this seminar on wind turbines. I am Nishant Kumar Jha, a mechanical engineering student from Sri Venkateswara College of Engineering. The purpose of this seminar is to provide you with a comprehensive understanding of wind turbines and the significance in the renewable energy sector. In this seminar, you can expect to learn the fundamentals of wind turbines, including how they work, the various types, and the factors that affect their efficiency. You will also gain insight into the design and manufacturing of wind turbines, as well as the operations and maintenance procedures required to keep them functioning optimally. Furthermore, we will explore the environmental and economic impacts of wind turbines, including the role in reducing greenhouse gas emissions, improving air quality, creating jobs, and reducing reliance on fossil fuels. By the end of this seminar, you will have a solid understanding of the various aspects of wind turbines, from their design and operation to the environmental and economic benefits. Whether you are interested in pursuing a career in the renewable energy sector or simply curious about the technology behind wind turbines, this seminar is for you. So let's dive in and explore the exciting world of wind turbines. So coming on to our first chapter, that is the introduction part, where we'll be learning about the history of wind turbines and the significance in the renewable energy sectors. History of wind turbines. Wind turbines have been around for thousands of years, with the first known wind-powered machine believed to have been built by the ancient Greeks in the 1st century AD. The machine, called a wind wheel, was used to grind grain and pump water. In the late 1800s, wind turbines began to use to generate electricity, with the first electricity generating wind turbine patented in the US in 1888 by Charles Brush. These early wind turbines were relatively small and inefficient, with most of the electricity generated being used to power individual homes and farms. It wasn't until the 1970s, with the oil crisis and growing concerns about the environment, that wind turbines began to be viewed as a viable source of renewable energy. Governments around the world began to invest in wind energy, leading to significant advancement in wind turbine technology. Today, wind turbines are one of the fastest growing sources of renewable energy, with over 3 lakh wind turbines installed worldwide and a total capacity of over 750 gigawatts. Wind energy is now competitive with traditional energy sources such as coal and natural gas, and it is projected to continue to grow in popularity as countries strive to reduce their greenhouse gas emissions and transition to cleaner energy sources. Wind turbines are a significant source of renewable energy because they provide a clean and sustainable source of electricity without producing greenhouse gas emissions. They can be installed in both rural and urban areas, making them a versatile source of energy, and they can be integrated with other renewable energy sources such as solar and hydropower to provide a reliable and stable source of electricity. Additionally, wind turbines have the potential to create jobs and stimulate economic growth in the renewable energy sectors. Moreover, wind turbines have a relatively short construction time and a long lifespan, making them a cost-effective source of energy over the long term. The cost of wind turbine or wind energy has also decreased significantly over the years, making it increasingly affordable for consumer and businesses. Wind turbines also offer a level of energy independence as they are not reliant on finite fossil fuel resources. This means that countries that are dependent on imported oil and gas can reduce their reliance on foreign sources of energy by investing in wind energy. In addition to the environmental and economic benefits, wind turbines have also become iconic symbols of the renewable energy movement. They are often featured prominently in images and advertisements promoting clean energy, and their sleek and futuristic design has captured the public's imagination. Energy consumption in India. India is the world's third largest consumer of energy after China and the United States. The country's total energy consumption has been increasing rapidly over the past few decades due to its growing population and expanding. In 2019, India's total energy consumption was around 2,359 million tons of oil equivalent with a mix of traditional and renewable sources. Indian energy consumption is dominated by coal, which accounts for over 55% of the total energy consumed in the country. India has the world's fourth largest coal reserves, and the coal industry plays a significant role in the country's economy. However, the use of coal has led to high levels of air pollution and greenhouse gas emissions, which are major environmental and health concerns. Oil is the second largest source of energy consumed in India, accounting for around 28% of the total energy consumption. Most of the oil consumed in India is imported, making the country vulnerable to price fluctuations in the global oil market. Natural gas is the third largest source of energy consumed in India, accounting for around 6% of the total energy consumption. India has a limited natural gas reserves, and most of the natural gas consumed in the country is imported. Renewable energy sources including solar, wind, and hydroelectric power account for a small but growing portion of India's energy consumption. In 2019, renewable energy sources accounted for around 10% of the total energy consumption in the country. The Indian government has set a target of achieving 175 gigawatt of renewable energy capacity by 2022, which includes 100 gigawatt of solar energy and 60 gigawatt of wind energy. Chapter 2: Fundamentals of Wind Turbine. In this, we'll be learning about the working of wind turbines, the components of wind turbines, the types of wind turbines, their advantages and their disadvantages, and the factors that affect wind turbine efficiency. Working of wind turbines. So wind turbines work by harnessing the kinetic energy of wind and converting it into electrical energy. Here's a basic overview of how a wind turbine works. The wind flows over the blades of the turbine, causing them to rotate. The blades are connected to a shaft which spins as the blade rotates. Then the shaft is connected to a generator which converts this rotational energy into electrical energy. And this electrical energy is then transmitted through a transformer to increase the voltage and sent to the electrical grid for distribution. Most modern wind turbines have three blades, although some have two or four. The blades are designed to capture as much energy from the wind as possible while minimizing drag and turbulence. The length and shape of the blades can vary depending on the size and location of the turbine. Wind turbines also have a number of other components, including a lower gearbox, a tower, brakes, and control system. The tower supports the turbine and raises it high above the ground to capture the strongest winds. The gearbox converts the slow rotation of the turbine blades into a faster rotation that is necessary to turn the generator. The brakes are used to stop the turbine in high winds or for maintenance. The control system monitors the wind speed and direction and adjusts the orientation of the blades to optimize energy production. Overall, wind turbines are highly efficient and effective way to generate clean renewable energy from the power of the wind. Components of wind turbine. So wind turbines have several components that work together to generate electricity from the wind. Here are the main components of a wind turbine. First one is the rotor blades. The blades of a wind turbines are typically made of lightweight and durable materials such as fiberglass or carbon fiber. They are designed to capture the kinetic energy of the wind and turn it into rotational energy. Next is the rotor hub. The rotor hub is the central point where the rotor blades are attached. It sits atop the tower and rotates with the blades. Third is the nacelle. The nacelle is a protective cover that houses the gearbox, generator, and the other components that convert the rotational energy of the blades into electrical energy. Gearbox. The gearbox is a complex system of gears and shafts that increases the rotational speed of the rotor blades from a few rotations per minute to several hundred rotations per minute, which is required to turn the generator. The generator converts the rotational energy of the rotor blades into electrical energy. The most common type of generator used in wind turbine is a three-phase synchronous generator. Tower. The tower is a tall structure that supports the nacelle and the rotor blades and raises them to a height where the wind is stronger and more consistent. The height of the tower can range from 30 meters to over 100 meters depending on the size of the turbines. The controller is a computerized system that monitors and controls the operation of the wind turbine, including blade pitch, rotor speed, and power output. The brakes. These brakes are used to slow down and stop the rotor blades in case of emergency or maintenance. Yaw system. The yaw system is responsible for orienting the rotor blades to face the wind, ensuring that the turbine captures as much energy as possible. Together, these components work in harmony to harness the power of wind and generate clean, renewable electricity. So now talking about the different types of wind turbine. So there are two main types of wind turbines. One is the horizontal axis wind turbine and the vertical axis wind turbine. Horizontal axis wind turbines. The horizontal axis wind turbines are the most common type of wind turbines used today. They have blades that rotate around a horizontal axis and face into the wind. These turbines are typically tall with the rotor placed at the top of a tower and can range in size from small residential turbines to large utility scale turbines. There are two types of horizontal axis wind turbine, upwind and downwind. These upwind turbines, the rotor is positioned upwind of the tower, meaning that the wind hits the blade before it reaches the tower. In downwind turbines, the rotor is positioned downwind of the tower, meaning that the wind passes over the tower before it hits the blades. Then comes the vertical axis wind turbine. The vertical axis wind turbines have blades that rotates around the vertical axis and can capture wind from any direction. These turbines are typically shorter than horizontal axis wind turbine and can be used in a variety of locations including urban areas. There are mainly two types of vertical axis wind turbine, Darius wind turbine and Savonius wind turbine. The Various wind turbines have a vertical axis and use curved blades that resembles an egg beater. As the blades rotate, they create lift which turns the rotor. The Darius turbines are often used for small-scale applications. Then comes the 7-year wind turbine. These turbines have a vertical axis and use curved blades that resembles a half cylinder. As the blades rotate, they create both lift and drag, which turns the rotor. 7-year turbines are often used for low-speed applications such as for water pumping or ventilation. So now let's talk about the advantages and disadvantages of horizontal axis wind turbine. So if we talk about the advantages of horizontal axis wind turbine, so the first point is efficiency. Horizontal axis wind turbines are generally more efficient than the vertical axis wind turbines and can generate more power for a given rotor size. Second one is the better at high altitudes. Horizontal axis wind turbines are typically taller than the vertical axis wind turbines, making them better suited for use in high altitude locations with stronger winds. Lower maintenance cost. These horizontal axis wind turbines are relatively easy to maintain and repair, which can result in lower maintenance cost over time. Availability of technology. Horizontal axis wind turbines have been used for many years and are a well-established technology, which means that there is a lot of knowledge and expertise available to support their use. Good for large-scale power generation. These horizontal axis wind turbines are well suited for large-scale power generation, making them a good option for commercial and utility scale wind farms. Talking about the disadvantages, so this horizontal axis wind turbines can generate significant noise levels which can be concern for nearby residents. They have an impact of wildlife. Horizontal axis wind turbine can also have a negative impact on wildlife, particularly birds and bats which can collide with the blades. Large area is required. This horizontal axis wind turbines require a large land area for installation which can be a limitation in some locations. The horizontal axis wind turbines require a minimum wind speed to generate electricity, which means that they may not be suitable for use in areas with low wind speeds. And initially, they're expensive to install, which can be a barrier to the widespread area, especially in developing countries, can be more. Overall, horizontal axis wind turbines are a well-established technology that can be used for large-scale power generation, but they have some limitations, including their impact on wildlife and the need for adequate wind speed to generate electricity. So talking about the advantages and disadvantages of vertical axis wind turbine. So low wind speed operations. The vertical axis wind turbines are able to operate in lower wind speed than horizontal axis wind turbines, which make them a good option for use in urban and suburban areas where wind speeds may be lower. They have a reduced impact on wildlife and they are easy to install and maintain. They are omnidirectional, that is, vertical axis wind turbines are omnidirectional, meaning they can generate electricity from wind coming from any direction, and they are aesthetically pleasing. Talking about the disadvantages, they have a lower efficiency. These vertical axis wind turbines are typically less efficient than the horizontal axis wind turbine and may generate less power for a given rotor size. Larger footprint. Vertical axis wind turbines require a larger physical footprint than horizontal axis wind turbines, which can be a limitation in some locations. Limited scalability. The vertical axis wind turbines are generally not well suited for large scale power generation, making them more suitable for small scale and residential applications. More difficult to integrate into the power grid. Vertical axis wind turbines may be more difficult to integrate into the power grid than horizontal axis wind turbines, which can limit their use in utility scale applications. Higher starting torque. Vertical axis wind turbines have a higher starting torque than horizontal axis wind turbines, which can make them more susceptible to damage in high speed. Overall, vertical axis wind turbines have some advantages such as their ability to operate in low wind speed and reduced impact on wildlife, but also some limitations, including their lower efficiency and limited scalability. Factors affecting the efficiency of wind turbine. Wind turbine efficiency is affected by various factors, including wind speed, air density, blade design, temperature, turbulence, altitude. Now let's see each of them one by one. Wind speed. The most significant factor that affects wind turbine efficiency is the wind speed. The amount of power a wind turbine can generate is proportional to the cube of the wind speed. Therefore, a slight increase in wind speed can significantly enhance the efficiency of wind turbine. Air density. The air density is another critical factor that influences the efficiency of wind turbine. High air density can improve the efficiency of the wind turbine as it results in more air molecules hitting the turbine blades, thereby generating more power. Blade design. The design of the wind turbine blades can also affect its efficiency. A blade that is too heavy or too light can reduce the amount of power generated by the wind turbine. The blade's shape and angle also play a crucial role in the wind turbine's efficiency. Temperature. Temperature can also impact wind turbine efficiency. As the temperature increases, the air density decreases, which can negatively affect the wind turbine's efficiency. Turbulence can cause uneven wind flow, resulting in fluctuating power generation by the wind turbine. Therefore, minimizing turbulence is crucial for maximizing the wind turbine efficiency. Altitude. The altitude at which a wind turbine is installed can also affect its efficiency. Higher altitude locations tend to have higher wind speed, resulting in increased power generation. In conclusion, wind speed and air density are the most significant factors that affect wind turbine efficiency, while blade design, temperature, turbulence, and altitude are also important considerations for maximizing the power generation. Chapter 3: Design and Manufacturing. Here we will be discussing the design consideration of wind turbines, the manufacturing process for wind turbines, the challenges associated with scaling up of wind turbine blades. Design consideration. Wind turbine design consideration can significantly impact the efficiency, durability, and cost effectiveness of a wind turbine. Key design considerations for a wind turbine include the blade shape, number of blades, and material used, among others. So let's talk about the blade shape. The shape of wind turbine blades can affect the aerodynamic performance of the turbine and ultimately its efficiency. Blades are typically designed to have a curved shape aerofoil that generates lift as wind passes over the blade. There are many different blade shapes available, including flat, curved, and twisted designs. Some designs may be more suited for specific wind conditions, while others may be more suitable for particular type of turbines. Number of blades. The number of blades can also affect the efficiency of wind turbines. Most commercially wind turbines have 3 blades, but some designs may have 2, 4, or more. A higher number of blades can improve the stability of the turbine in high winds, but can also increase the complexity and cost of the turbine. Material used. The material used to make wind turbine blades must be strong, durable, and lightweight. Common material used in wind turbine blades include fiberglass, carbon fiber, and aluminium. The choice of material will depend on factors such as cost, durability, and the specific wind conditions at the turbine site. Rotor diameter. The rotor diameter is an important design consideration as it affects the amount of wind energy that can be captured by the turbine. A large rotor diameter will generally result in higher power output and efficiency, but may also increase the cost and complexity of the turbines. Tower height. The height of the wind turbine tower can also affect its efficiency. A taller tower allows the turbine to capture higher wind speeds, which can improve the efficiency of the turbine. However, a taller tower may also increase the cost of the turbine and require most expensive infrastructure. Gearbox design. The gearbox is an essential component in a wind turbine that converts the low speed rotation of the rotor into high speed rotation of the generator. The gearbox design must be carefully considered to ensure that it is efficient, durable, and reliable. In summary, designing an efficient wind turbine requires careful consideration of several design factors including blade shape, number of blades, material used, rotor diameter, tower height, and gearbox design. These factors must be optimized to ensure that the turbine is cost effective, durable, and able to capture as much wind energy as possible. Manufacturing process for wind turbines. The manufacturing process of wind turbines can vary depending on the type and size of the turbine as well as the manufacturer. However, a typical manufacturing process may involve the following steps. Blade production. Wind turbine blades are typically made up of fiberglass and carbon fiber reinforced plastic. The production process starts with the creation of a mold for the blade. The mold is then used to lay up the composite material, which are typically done by hand. Once the composite materials have curved, the blade is trimmed, finished, and inspected. Tower production. Wind turbine towers are typically made up of steel or concrete. For steel towers, the manufacturing process involves rolling steel plates into cylindrical shapes, welding the seams together, and painting the tower. For concrete towers, the tower segments are cast on site or in the factory and then transported to the wind turbine site. Nacelle production. The nacelle is the housing that sits on the top of the tower and contains the generator, gearbox, and other components. Nacelles are typically made up of steels and are produced using traditionally manufacturing techniques such as welding, bending, and cutting. Generator and gearbox production. The generator and gearbox are critical components of the wind turbine that converts the rotational energy from the blades into electrical power. These components are typically manufactured using traditional machining techniques such as milling and turning. Assembly. Once the individual components are produced, they are assembled on site or at the factory. The blades are mounted onto the hub and the hub is attached to the nacelle. The nacelle is then lifted onto the tower and bolted in place. In recent years, manufacturers have also started to incorporate modern manufacturing techniques such as 3D printing into the production process. 3D printing can be used to produce complex parts and components more quickly and with less waste than traditional manufacturing techniques. Additionally, advancement in automation and robotics are also being used to streamline the production process and improve the efficiency. Challenges associated with scaling up of wind turbine. Scaling up wind turbine presents several challenges including transportation and installation logistics. As wind turbines get larger and more powerful, the components become heavier, more difficult to transport, and more complex to install. Some of the main challenges associated with scaling up wind turbines include transportation. As wind turbine components get larger, transporting them to the installation site becomes increasingly challenging. Components such as blades, towers, sections, and nacelles may need to be transported by oversized trucks, ships, or even specialized aircraft. This can be expensive, time consuming, and can require specialized permits and approvals. Installation logistics. Installing larger wind turbines requires specialized equipment, skilled personnel, and careful planning. Larger cranes and lifting equipments may be required to lift and position the heavy components into place. The installation process may also require more specialized skills such as electrical or hydraulic engineering to ensure that a turbine is installed safely and correctly. Site constructions. As turbines get larger, they require more space to operate effectively. This can be challenging in areas with limited available space, such as urban environments. Additionally, larger turbines may require stronger foundation structures to support the increased weight and force generated by the turbine, which can be difficult to construct in certain soil or geological conditions. Cost. As wind turbines get larger, they become more expensive to manufacture, transport, and install. Additionally, larger turbines may require more frequent maintenance and repairs, which can add to the overall cost of the project. Environmental concerns. As wind turbines get larger, they can have a greater impact on the local environment, including wildlife and ecosystem. This can lead to increased regulatory and environmental compliance requirement as well as potential opposition from local communities. In summary, scaling up wind turbines presents several challenges related to transportation and installation logistics, as well as site constraints, cost, and environmental concerns. These challenges must be carefully considered and addressed to ensure that the larger wind turbines can be installed safely, efficiently, and cost effectively. Chapter 4: Wind Turbine Operations and Maintenance. Here we will be studying about the importance of proper maintenance for wind turbines, the role of remote monitoring and predictive maintenance, safety consideration associated with operating and maintaining wind turbines. Importance of proper maintenance. Regular maintenance procedures are required to ensure that the wind turbines are operating efficiently, reliably, and safely. Neglecting maintenance can lead to reduced energy output, increased downtime, and even safety hazards. Proper maintenance of wind turbines involves various procedures, which include lubrication. Wind turbines have many moving parts that require lubrication to prevent wear and tear. Lubrication helps to reduce friction and heat buildup, which can cause parts to wear out prematurely. Regular lubrication of bearings, gears, and other moving components is crucial to ensure that the turbine operates smoothly. Inspection. Regular inspection of the turbine is essential to identify and address any issues that may arise. Inspection includes a thorough examination of the blades, tower, and the other components to detect any damage or wear that may affect the turbine's performance. Cleaning. Wind turbines are exposed to various environmental elements such as dust, dirt, and bird droppings, which can accumulate on the blades and reduce their efficiency. Regular cleaning is necessary to remove these elements and maintain optimal performance. Repair. Repairs may be necessary to replace damaged or worn parts. Some parts, such as the blades, may need to be replaced entirely if they are severely damaged. It is essential to perform repair promptly to prevent further damage to the turbine. Upgrades. As technology advances, new components and systems may become available that can enhance the performance and efficiency of the wind turbine. Upgrades may include installing new sensors, control systems, or other advanced technology that can improve the turbine's performance. In overall, proper maintenance is critical for the optimal performance, safety, and longevity of wind turbines. Regular inspection, lubrication, cleaning, repairs, and upgrades are necessary to ensure that the turbine operates efficiently and reliably, minimizing downtime and safety hazards. Role of remote monitoring. Remote monitoring and predictive maintenance are crucial components of modern wind turbine management system, and they play a significant role in optimizing wind turbine performance. Remote monitoring and predictive maintenance utilize advanced sensors and data analytics to identify potential issues and predict equipment failures before they occur. Remote monitoring systems continuously collect and analyze data on various parameters such as vibration, temperature, and energy production from the wind turbine's various components. This data is transmitted to a central control room where technicians can analyze the data and identify potential issues. Remote monitoring can detect problems such as equipment malfunctions, imbalances, and component wear, and alert the maintenance team to address the issue before it leads to costly downtime or safety hazards. Predictive maintenance utilizes data analysis to identify patterns and predict when maintenance is required. Predictive maintenance algorithms use machine learning and artificial intelligence to analyze data collected from the wind turbines' various sensors and identify patterns that indicate when maintenance is required. Predictive manufacturing or predictive maintenance can also use historical data to develop models that predict equipment failures and recommend maintenance actions before they occur. The benefits of remote monitoring and predictive maintenance is optimizing wind turbine performance are numerous. This technology enables wind farm operators to reduce downtime and maintenance costs by addressing potential issues before they lead to equipment failure or safety hazards. Remote monitoring and predictive maintenance also helps optimize energy production by identifying equipment issues that may reduce turbine performance. Safety consideration associated with operating and maintaining wind turbines. Operating and maintaining wind turbines can be a dangerous undertaking, and safety consideration should be a top priority for everyone involved. Two significant safety hazards associated with wind turbines are blade failure and electrical hazards. Blade failure is a potential risk that can result in injury or damage to property. The high speed rotation of wind turbine blades can lead to fatigue, erosion, or manufacturing defects which can cause blade failure. Blade failure can also occur due to lightning strikes, bird strikes, or extreme weather events. A failed blade can cause significant damage to the turbine and surrounding area and may result in injury or death if it strikes a person. To mitigate this risk, regular inspections and maintenance are essential to identify and address any issues that may lead to blade failure. Additionally, warning systems and safety protocols should be in place to ensure that workers are not in the vicinity of a wind turbine during high winds or extreme weather events. Electrical hazards are another safety concern associated with wind turbines. Wind turbines generate high voltage electrical power which can be deadly if not handled correctly. Electrical hazards can result from faulty wiring, equipment failure, or contact with live wires. To mitigate this risk, proper training and safety protocols must be in place for workers involved in the operation and maintenance of wind turbines. Workers should be trained to identify and avoid electrical hazards, and the proper personal protective equipment such as insulated gloves and safety harnesses should be used when working near electrical components. Other safety considerations associated with wind turbines include fall hazards, fire hazards, and transportation risks. Wind turbine towers are tall structures, and fall from a height can result in severe injury or death. Proper safety equipment and training must be in place for workers involved in climbing wind turbine towers. Fire hazards can result from equipment malfunctioning or lightning strikes, and proper fire safety protocols should be in place to minimize the risk of fire. Finally, transportation risks associated with the transportation of the wind turbine components to and from the wind farm site should be carefully managed to avoid accidents or damage the equipment. In conclusion, operating and maintaining wind turbines can be hazardous and safety consideration must be a top priority. Blade failure and electrical hazards are two significant safety concerns associated with wind turbines, but other hazards such as falls, fire, and transportation risk must also be addressed. Proper training, safety equipment, and safety protocol must be in place to minimize the risk associated with wind turbine operations and maintenance. Chapter 5: Environmental and Economic Impacts of Wind Turbine. Here we'll be studying about the environmental benefits of wind turbines, economic benefits of wind energy, and negative impacts of wind turbines. Environmental and economic benefits of wind turbine. Wind turbine offer numerous environmental benefits, making them an essential part of the transition to a cleaner and more sustainable energy future. Two significant environmental benefits of wind turbines are the reduction in greenhouse gas emissions and the improvement in air quality. Greenhouse gas emissions are a significant contributor to the climate change. The burning of fossil fuels such as coal, oil, and gas to generate electricity releases carbon dioxide and other greenhouse gases into the atmosphere, trapping heat and warming the planet. Wind turbine generates electricity without emitting any greenhouse gases, making them an excellent alternative to traditional fossil fuel-based power plants. In 2020, wind power prevented an estimated of 1.1 billion tons of carbon dioxide emissions globally, equivalent to taking 233 million cars off the road for a year. Wind turbine also improve air quality by reducing the amount of pollution from traditionally power plants. Fossil fuel-based power plants release pollutants such as sulfur dioxide, nitrogen oxides, and particulate matter into the air, leading to smog, acid rain, and respiratory problems. Wind turbines generate electricity without producing any harmful emissions, leading to improved air quality in the surrounding areas. The American Wind Energy Association estimates that wind power has saved over 100 billion gallons of water and avoided the emission of over more than 590 million metric tons of carbon dioxide since 2000. Wind turbines also have a smaller environmental footprint than traditional power plants. Wind turbines can use far less land than traditional power plants, and the land surrounding the wind turbines can still be used for farming, grazing, or other activities. Additionally, wind turbines have minimal water requirements, using only a small amount of water for cleaning and maintenance. Wind energy has a significant economic benefits in India, which is one of the fastest growing markets for wind energy in the world. Two significant economic benefits for wind energy in India are job creation and reduced reliance on fossil fuels. Job creation is one of the most significant economic benefits of wind energy in India. The wind energy sector in India is a major employer with over 60,000 people employed in various aspects of the industry, including project development, construction, operation, and maintenance. The Indian government has set a target of installing 60 gigawatt of wind power capacity by 2022, which will create many new jobs in the sector. These jobs are often located in rural areas where employment opportunities are limited, providing a boost to local economies. Reduced reliance on fossil fuels is another economic benefit of wind energy in India. India is heavily dependent on imported fossil fuels, which are subjected to price fluctuation in global markets. By investing in wind energy, India can reduce its reliance on imported fossil fuels, improve energy security, and reduction in exposure to price volatility. The Indian government has set a target of achieving 175 gigawatts of renewable energy capacity by 2022, including 60 gigawatt of wind power capacity. This target will help India reduce its reliance on fossil fuels and move towards a more sustainable energy future. In addition to job creation and reduced reliance on fossil fuels, wind energy has other economic benefits in India. Wind energy projects can generate revenue for local communities through land lease payments, and the development of wind energy infrastructure can create demand for locally manufactured equipment and materials. Wind energy can also help India meet its energy demand while reducing its carbon footprint, improving air quality, and mitigating the impacts of climate change. Negative impacts of wind turbines. While wind energy has numerous benefits, including environmental and economic, it also has some potential negative impacts that should be considered. Two of the most significant negative impacts of wind turbines are noise pollution and visual impacts. Noise pollution is a common concern with wind turbines, particularly for people who live in close proximity to them. Wind turbines generate noise as the blades turn, which can be disturbing for nearly residents, affecting their quality of life. However, noise pollution from wind turbines can be mitigated through the use of sound barriers such as tree belts or walls, and by siting turbines away from residential areas. Visual impacts are another potential negative impact of wind turbines, as they can be seen from mile around and can change the landscape appearance. This can be a concern for people who value the natural beauty of the area where wind turbines are located. However, visual impacts can be mitigated through careful siting and design of wind turbines, such as locating them in areas that are already visually impacted, such as nearby highways or industrial areas, or designing them to blend with the landscape, such as painting them in a natural color. Other potential negative impacts of wind turbines include bird and bat mortality, which can be mitigated through careful siting and design of wind turbines, and the potential for electromagnetic references, which can be minimized through proper grounding and shielding of electrical components. Conclusion. Wind energy is a crucial component of the transition to a cleaner and more sustainable energy future. As the technology for wind turbine continues to evolve and improve, wind energy is becoming increasingly cost effective and efficient, making it a viable alternative to traditional fossil fuel based energy generation. The future of wind turbine looks promising, with continued growth expected in the industry. Wind energy is expected to become even more cost competitive in the coming years as the technology improves and economics of the scales are realized. In addition, advances in energy storage technology will allow wind energy to provide a more reliable and stable source of electricity. As the world grapples with the urgent need to address climate change, wind energy will play an increasingly important role in reducing greenhouse gas emissions and transitioning to a low carbon energy system. Wind turbines can be deployed in a variety of settings, from offshore wind farms to small scale distributed wind projects, providing a flexibility and adaptable source of energy that can meet a range of energy needs. However, as with any form of energy generation, it is important to consider potential negative impacts of wind turbine and to address them through careful siting and design, as well as the use of appropriate mitigation measures. By taking a holistic approach to the deployment of wind turbine, we can ensure that they provide the maximum benefit to society while minimizing the potential negative impacts. Thank you for being such a great audience. If you have any questions, you can mail me at my email ID, or you can write on the comments below. Thank you.